Okay, so this will be the first video from your Chapter 3 test review. This will cover questions 1 through 6. Alright, so you want to make sure that you solved for y on these first two because we're just using the calculator for them. I really don't mind if you use the calculator to check, 3 through 10, but you have to show the work on 3 through 10. So these first two already have y solved, so we're going to pull up the calculator. If you have something in there, make sure you take it out, and you'll plug that in. So you've got x plus 4, and then you've got negative 2x minus 2. And we're looking for where these two cross. And I apologize if this graph doesn't show up on the screen because I can't tell if it's going to in the video or not. So if it's not up there, maybe it'll pop up later. Alright, so it looks like they cross at negative 2, but just to be sure, we'll use our calculate the trace menu. So second trace, find your intersect there, option 5. So this is my first curve, and it comes up in blue, so that's fine, so press enter. Second curve will show up in red, enter. And then you're going to arrow really close over to that intersection and press enter. It tells you your intersection is at negative 2, 2. So that is your answer. Alright, number 2, we actually need to solve for y, so I would have to subtract the x and divide by negative 3. So that would give me negative x plus 6 over negative 3. The second equation, you would have to subtract the 7x and divide by negative 3. So that would give you negative 7x minus 12 over negative 3. And remember on these, it doesn't matter if you simplify them because your calculator doesn't discriminate. So get you a fraction. Alright, so this first one would be negative x plus 6 over 3. And this next one would be negative 7x minus 12 over negative 3. And I did not give you one that has a quadratic and a linear to graph and look at, but make sure you are prepared to do that for your test. So it looks like they cross here at, I think I've put something in wrong. Let me go back here. Oh, I did. This first one, I forgot my negative. So if you forgot your negative, make sure you put it in there. Ah, that's better. So I have this line here, then I've got this line here. Looks like they cross at negative 3, negative 3, but I'm going to find the intersect anyways. So second trace, option 5. This is my first curve, the blue one. Enter. This is my second curve, the red one. Enter. And then arrow over until you get to that spot where they cross. Just get really close. Press enter, and it tells you negative 3, negative 3. Alright. So we had already discussed that when you have two linear equations, if you just solve for y for both of them and set them equal to each other, you can solve them that way. And then we went over to another way to do this last week, where you can multiply by something and then add the two together to eliminate. So I think that's what I'll do here because you guys seem to really like that. So I'll do that on these two, but know that you can solve for y in both of them and set them equal to each other. So if you look at these two equations, if I added them together, I could eliminate the y pretty easily if this was a positive 8. So I'm going to multiply this by negative 8. So when I do that, that gives me negative 42x plus 8y equals 0. And I put 42, that's supposed to be 48. So negative 48, sorry. Alright, now I can add these two together. So I got 7 minus 48, which is going to give me a negative 41x. The 8y will cancel. So all I have to do is divide by negative 41, and x is 0. Then I can go back up and plug x in. So I have 6 times 0 minus y equals 0. Well, this will be 0. That's just nothing right there. So I have negative y equals 0. Well, if you divide by the negative, y is still 0. So I would have 0, 0. Alright, so if you look at these two, um, it might be easier to solve for y and set them equal to each other, but I'm still going to do the elimination method. Alright, so let's eliminate the y's. So the smallest thing that both of them go into is 12, so I can make this a positive 12 by multiplying everything by 2. And can I make this a negative 12 by multiplying everything by 3? So that would give me 8x plus 12y equals 44. And this would be negative 21x minus 12y equals negative 18. So now I'm ready to add those together. Negative 21 plus 8 is going to give me negative 13x. And then 44 minus 18 will give me 26. Sorry, that's a 13. Divide by the negative 13, and x is equal to negative 2. So now I just plug that back in. So I have 4 times negative 2 plus 6y equals 22. Sorry, my pen keeps not writing. So that gives me negative 8 plus 6y equals 22. Add the 8. And 6y equals 30. Divide by 6, and y is 5. So that point of intersection would be negative 2, 5. Okay, so if you look at these two, we can eliminate the y if this was a positive 4. So I'm going to multiply all of this by 4. So that would give me 28x plus 4y is equal to negative 20. And I can add that to this top. So 28 minus 14 would be 14. The y's are going to cancel, and 10 minus 20 is a negative 10. Sorry, guys. I'm getting ahead of myself again. See, it's like I'm here, but I'm really not here. Crazy. Just erase all that. We'll start over. Alright. I want this to be a 4. I don't want to multiply by 4, so I need to multiply by 2. Y'all were thinking that the whole time, weren't you? I need to multiply by that. So this would give me positive 14, and that would give me positive 4 and negative 10. So then when I add that with the top, if you notice, everything's the opposite sign. So this cancels, I just have 0 over here. These two cancel. And what you get is two things that are the same. So since these are both the same, that means you have infinitely many solutions. If you get two things, when all your variables cancel, you get two things that are not equal, you don't have any solutions. But when you get two things that are equal, you have infinitely many solutions. Alright, so this one would be easy to eliminate the y because I just need one of these to be negative. So let's just multiply the second one by negative 1. You could do the first one too, it doesn't matter. Alright, so this would give me positive x, negative 6y, and negative 15. So when I add those together, negative 5x and positive 1x would give me negative 4x. The y's will cancel, and then negative 15 plus 3 would be negative 12. So when I divide by the negative 4, x is positive 3. Then I go back up and plug in. And it doesn't matter which one you plug into. I'm just going to go with the second one. So I've got negative, plug in the 3, plus 6y equals 15. So I add the 3. I get 6y equals 18. Divide by 6, and y is 3. So that point of intersection, or the solution to my system, is 3, 3. So this concludes video number 1. I hope you've enjoyed the ride.